Now we are going to learn the light meter. What is a light meter? A light meter is a device that reads the light inside the room that you are in. Light meters can be used for studio lighting or for ambient light or for sunlight. But usually for sunlight and ambient light, we don't use a light meter. Why is that? Because, as you know, inside the camera, there is a light meter built in the camera. So whenever you're taking a shot in the outdoors or indoors without studio light, you can see the meter in the camera either blinking in the middle, which means the picture is well lit, or it could be to the left side or to the right side. Whenever you see the light meter of the camera to the left side, it means that the picture will be underexposed. It will be a dark image. Whenever you see the light meter of the camera to the right, it means that the picture will be overexposed. It will be burned out. So usually we can rely on the light meter in the camera when we are shooting in the outdoors, so we will not need a light meter. But when you are using studio light, like in our case, the studio light is a strobe. The strobe is usually turned off. It only turns on when you click the shutter speed of the camera. For example, this strobe is currently powered on. But if I try to meter it, I will only meter the modeling lamp light. I will not be metering the flashlight. The flashlight will only be on when I take a picture with the camera. It will blink for a period of a second, and then it will be turned off, and I can only see the modeling light. So how can I measure this light that will only come for a period of a second when I press the shutter release button? To do this, I need a separate device, separate from the camera, to measure this light. So the light meter is used for this job. Since I can access the strobe wirelessly, whenever I want, I can let the flash light by hitting the trigger button over here without clicking the shutter release on the camera. Therefore, the process will be easy. I can meter this light by using the wireless trigger and putting the light meter in front of it. For sure, we will learn how to use it and the controls. But the idea is I can put the light meter in front of the strobe and I can let it give light wirelessly. And by this, I will read the measurement on the light meter and then put the same settings on my camera. So the light meter will allow me to meter such lights which do not give light before the release button is pressed. And therefore, I can get the right measurement like the aperture, shutter speed, and so on, and put them on my camera. Not only that, when you are using multiple lights, for example, in the studio, you might have more than one light. So here I have one light and another light. You can have up to 6 lights or even more, depending on the setup. When you have multiple lights, the best thing is to use a light meter so you can meter everything, get correct measuring, and then put it on the camera. Let's first start by looking to the controls and the settings inside the light meter, and then learn how to use it and enter to the debate, is it really needed to use a light meter or not? So let's see a closer look for the controls of my light meter. There are 3 things that you can control in the light meter, which are the shutter speed, the ISO, and the aperture. The number here, 125, is the shutter speed, and this means it is 1/125. Usually in the studio, we use always 1/125 because this speed is enough to freeze anything. Even if the hair of the model is flying, we can freeze it by this speed. And since we have a lot of light in the studio because of the strobes, we are not afraid of any combination that we can put because we have enough light to give to the camera whatever the aperture and the ISO and the shutter are. But since there's a lot of light, it's better to have a clean picture. This means it's better to lower the ISO as much as possible. In other words, it's better to use ISO 100. And the ISO is shown here, and this is ISO 100. So usually in a studio, we always use ISO 100 and shutter 1/125 because we have enough light to give to the camera, regardless of the aperture that we are going to use for it. I can change the ISO and the shutter. For example, the shutter speed, I can change it by dialing the dial over here. So for example, 1/60, 1/30, and so on. And if I want to change the ISO, I can click on the ISO button below and change it. So 80 64, and so on. I'll return it back to 100. The number 0 is the aperture. And currently it's 0 because I'm not measuring any light. To measure light, there's a button here which I click, and when I click, I can now let the strobe give light. When light hits this part of the light meter, it will show me the appropriate aperture value based on the shutter and the aperture and the ISO that I selected. So the aperture value will appear in the position of the number 0. The aperture is displayed on the light meter with a small decimal value of 10 points. For example, if you are metering and you are targeting f8, for sure from the first time you will not reach f8. Let's say the meter showed you f8.0.4. This small 0.4, the 4 number, is of 10 points. For example, when it shows 8.0.4, it means you are 4 points above 8. Or you are 6 points below 11, which is the next f-stop number. So if you are 8.0.4 and you would like to reach exactly 8, you will use your wireless trigger and you will click on the -4 times. So when it is 8.0.4 and you go 4 times negative, it will be 8.0 exactly. Or if you are f8.0.4 and you'd like to reach f11, from 4 to reach the 10, since it's 10 points, you go only 6. So I click on the plus 6 times and you will go from f8.0.4 to f11 exactly. So controlling it's really easy. You just put the shutter speed and the ISO and you click this button to take a reading, and then you'll use the wireless trigger to go up or down based on the small number that you will see next to the aperture number. Where do you put the light meter when you are going to meter light? If you are taking a portrait for a person, for example, assume I'm the person, you put it under the chin. So something like here. If you put it for the height of your nose, it differs. The distance from here to here might differ around half a stop. So you have to be careful. It depends on your taste, but usually for portraits, we take it under the chin. For subjects, it depends on the nature of the subject. Now the second question, how do you orient the light meter? First, you have to look at the top of the light meter. If you look here, you see that there is a semisphere, half a sphere. This semisphere is the area that reads the light. So there are two ways, or at least there are two traditions to use the light meter. For example, consider the light is from this side. There's one saying that says if you would like to measure the light, you have to rotate it towards the light, so I can read the light from here. Another saying says, no, you should not rotate it to the light, you should rotate it to the camera. So for example, if the camera is in front of me, even if the light is coming from this direction, I will put it straight. Well, personally, after using it a lot and study it, I believe it doesn't really matter. Because, as I told you, the top of the light meter is a semisphere, which means it's going to read light from 180 degrees. So since you are reading from 180 degrees, it doesn't really matter if you rotate it to this side or you keep it to this side. In all cases, I will test it in front of you right away, and I'll show you by numbers that it's not really that big difference. But personally, when I do photography, I do not rotate it to the light, I rotate it to the camera. I believe I should know the aperture value that the camera is looking at and not what the light is, the orientation of the light. So whenever I'm doing the metering, I will meter to the direction of the camera. So now let's see the setup that we did to test and try our light meter. Our setup is really very simple. We just have this Gretak Macbeth color checker that we are going to shoot with the camera, which is standing on a tripod, and we are going to see the results. Since the Gretak Macbeth color checker is a known item where all the colors in there, we already know their RGB values, it will be very easy and convenient for us to test it on our lighting setup. Because if the picture was underexposed or overexposed, then the reading of the colors on the Gretak Macbeth will be wrong, and it will be easy for us to spot that. So we are going to use this. The lighting is very simple. We have two lights, but we are going to use them one by one, and then we use both of them together. So these lights are mixed between soft light and hard light. We have here our softbox, which is a soft light, and we have here our grid and honeycomb grid and reflector, which is hard light. So initially we will use only the softbox, then we will use only the reflector. This will prove to you that there is no difference for the light meter what type of light you're using. It will measure light regardless of the nature of the light, and it will give you correct answers. And then after we use each one alone, we are going to use both of them to see the results. Okay. F5.6.9, which means I am only 1 point far away from the next f-stop, which is F8, which means I need to click on my wireless trigger, the plus sign, only 1 time. Notice that now, although I increased the power, but the metering showed F5.6.8. It should have reached F8, while on the contrary, it went down by 1 point. This is because my hand is moving, and any slight change in your hand or the position of the light meter will affect the reading. This is why I said previously that if you put it under the chin or next to the nose, this is too much difference and it might be up to half a stop. So F8. If you do a rotation, also it's F8 because it's a semisphere, it has no real difference. So this is the first picture that we took on F8 for the Gretak-Macbeth color checker. Before talking about some details about this picture, let's say some notes about the Gretak-Macbeth color checker. The checker is usually used to do calibration for your colors or to do some color correction in your photography. Usually you use it if there's a color cast in the area that you are shooting in, so you can correct your colors from this checker because the colors in this checker are already known before. If we look to this table, it shows the RGB values of each color in the color checker. Therefore, we can easily compare our results to the numbers in this table to know if our colors are good or not, or to know the exposure of our photography is good or not. In our case, we are interested in the white, the neutral gray, and the black. Because in our case, we are interested only in measuring the exposure of the picture to see if the lights are good or not, if we have an overexposed image or an underexposed image. Also, it's good to keep an eye on the colors just to have an idea how the colors will appear when we have good exposure and how they will appear when we have wrong exposure. The Gretak-Macbeth color checker contains the most important colors that are used in photography, which are the RGB, red, green, blue, CMYK. Also, it has some important nature colors like the blue skies, like the greens, flowers, and 2 colors for skin tones, dark skin tones and bright skin tones. It also has a variation from white to black with different levels, which is used for color balancing or to measure the exposure of the picture. So let's put the RGB values for the white, neutral gray, and black that we found from our picture, and sure, we got these numbers from Photoshop. So we'll write them in white colors, and under them we are going to put in red color the numbers taken from the Gretak-Macbeth color checker table. The more our numbers are close to the Gretak-Macbeth color checker numbers, the more our exposure is correct. So if we look to the white values, we see that in our case, the white is 242, 243, 238, which is very close to the checker numbers, which are 243, 243, 242. This means that our exposure is very good. We don't have overexposed nor underexposed values. Looking to the neutral gray, our neutral gray is a little bit lighter than the checker. Our values are 133, 134, 136, compared to the checker 122, 122, 121, but in fact they are not very far from them, so they are considered to be good. Our black is a little bit darker than the checker black. Ours read 37, 37, 37, while the checker reads 52, 52, 52. So we're a little bit darker in black, but this is nice in photography as it will be more contrast. So in general, we can say that the lighting of this picture is good, and this picture is neither overexposed nor underexposed, so it is in good exposure state. So now we saw the results of F8. Now I would like to go to the next f-stop, but I want to do it in the wrong way. Instead of clicking 10 times on my wireless trigger to reach the next f-stop, I will click only 5 times, while on the camera I will put the next f-stop. This will produce an underexposed image because the light will be less than needed. And I want to do this just to see how the colors will really be affected when the metering is wrong. So 1, 2, 3, 4, 5. So f8.0.5. In this picture, we tuned our camera on f11, while the light meter was reading f8.0.5. This means we are half stop less than f11. This means that light is not enough for f11, and therefore the final result will be a little bit darker, so the image will be a little bit underexposed. This should be reflected in the RGB values of the white, gray, and black. So if you put the RGB values and compare them to the checker values, for example, in the white, we see that we have 226, 225, 221. In comparison, we should have something in the 240 level. So since we are less than 240, it means our color is darker. And just a small tip in case you don't know how the RGB values work, RGB values are from 0 to 255, where 0 is dark and 255 is bright. For example, if we have 000, it is totally black. If we have 255, 255, 255, it's 100% white. If we have something in the middle like 125, 125, 125, it is gray. So when the numbers are small, it means dark. When the numbers are high, it means bright. So the white should be around 240 based on the checker numbers. In our photography, in this case, the numbers were 226. We are getting 226 means that white is not as white as it should be and colors are a little bit dark, and this is because we are using f8.0.5 on the light meter instead of f11. To correct this, we should have increased the power of our strobe by 5 more points by clicking on the plus sign 5 times to reach f11. So we are half stop less than f11, and therefore the picture is a little bit dark. We can see this is reflected in the gray and the black. In the gray, we have around 106 values, while we should have around 122. And in the black, we have 25, while we should have around 50. So this picture is a little bit darker than it should be. And for the sake of the comparison, let's compare this to the previous one, which was correctly tuned on f8. Notice how this picture is a little bit brighter than the previous one, because this is the correct exposure. And just remember that here we had the white RGB values as 242, 243, 238, so they were very close to the Gretak-Macbeth color checker. So if you go back to the previous picture, we see how it is a little bit darker, and we can understand how half a stop can really affect the overall exposure of the image to produce a little bit darker picture. Now I will click 5 times on my wireless trigger to reach exactly the next f-stop to compare the half stop and the 1 stop to see the wrong one compared to the right one. So f11. In this picture we have the camera tuned on f11 and the light meter was reading f11. Therefore, this picture should be correctly exposed. If we look to the RGB values of the white and gray and black, we can see this is reflected on them. Once again, the white now is very close to the checker values, it's around 242, and the gray is also near to the checker values, and same thing for the black. If we'd like to compare this one, which is correctly exposed, to the previous one, which was shot on f11 but was exposed on f8.0.5, we can see that the wrong one is really a little bit underexposed. So this half stop is really noticeable. Once again, notice that in the underexposed one, the white was 226, while in the correctly exposed one, it is at 242. Let's now compare this picture to the first one, which was tuned at f8. Before, let's remember something. When we took the picture on f8, the light meter was reading f8 as well, so the exposure was correct. Therefore, the brightness of the picture was correct. And in this picture, the light meter was reading f11 and the camera also was tuned on f11. So also in this picture, the exposure is correct. This means when we compare these two pictures with each other, we should have almost identical exposure and we should not be finding any differences. So let's right away see the previous one, and we can see that they are almost identical, not only visually, also by numbers. The white is exactly the same RGB values, the gray is exactly the same, only the black is little bit different and very little bit differences. Here the black is 37, 37, 37, we're on f8. If we go to the f11, we see that the black is 34, 36, 35, so it's almost identical. This is a very important property when using good strobes. One of the important properties, as we said earlier in good strobes, is the ability to reproduce light correctly. So when we tuned the strobe on f11 correctly, it gave almost the same results when we tuned it on f8 correctly. So this is very important in photography, to be able to reproduce light correctly and give identical values on identical metering. Now I will go half stop above, which means I will click 5 times on my wireless trigger, but I will keep on the camera f11. So the light meter will read 11.5, but on the camera it will be f11. This is to compare an overexposed one with the normal one, and the overexposing is only half stop. 1, 2, 3, 4, 5. $11.5. So this example is the opposite of the first example, which is we have a wrong exposure, but this time it is a little bit overexposed while the previous example was underexposed. Here we have the light metered on f11.0.5 while the camera is tuned at f11. So we are half a stop more than the camera. So light is stronger, and therefore the final result will be a little bit overexposed. We can clearly see this by our eyes and by numbers. By the eyes, we can see that the red is a little bit overexposed and the skin tones are a little bit overexposed. If we look to the numbers, we can see that white now is almost reaching the maximum, which is 253, 253, 251. The maximum is 255, 255, 255. So we are much higher than the checker values. The gray is really high, it's now 166, while previously it was in the 130 something value, and we are way higher than the checker values. And the black is also very bright, it's 62, 64, 64. Previously we were getting 30 something values, so we are really much brighter. So the half stop has a really big difference, it affects the picture a lot. If we have another look to the previous picture, which was correctly exposed, we can see that really there's a difference, and here the colors are better and the exposure is much better. Now we are going to switch to the hard light. For sure, for the light meter, it does not matter if it's hard light or soft light. What matters between hard and soft is the final result, how we see the picture. But for the reading, the strength of light, it doesn't matter to the light meter, it can read any type of light. It is very important that when you are going to meter light, not to stand in front of the light. In other words, when I was metering this light, I was standing from this side. But now, since I want to meter this light, I'm standing from this side. If I stand from the second side and I put my hand above my item, I will be blocking some of the light and the metering will be wrong. So it's better always not to stand in front of the light. So 11.2. If I'd like to go to F16, this means I have to click 8 times on my remote trigger so the 2 reaches 10, because as I said, it is a 10 points. So 1, 2, 3, 4, 5, 6, 7, 8. $11.9, so, oops, sorry. Almost there, Faizan +1. 16.0. So 11.9. There's no big difference if I rotate it or keep it like this. So now we are at f16. This is the first picture that we take using the hard light. The previous pictures were taken using a softbox, which is a soft light. The softbox was standing to the right of the picture, while the hard light is on the left. The hard light is using a reflector and a honeycomb grid. By nature, hard light is a little bit stronger and a little bit brighter than soft light. This is reflected on the overall picture, which we can see in our eyes, and also is reflected on the numbers themselves. So now the white is 248, 248, 245. It should be around 243. So we are a little bit more than the checker values, but we are still in good range, and therefore our exposure is very good. Also, these numbers are a little bit higher than the previous numbers that we were getting, but are not really much higher. So once again, we are on a very good exposure. If you look to the gray, we're a little bit higher. Now we are on the 150 scale. The checker should be on 122, and previously we were getting less than 150. We were getting in around 130 something. So once again, this is the nature of the hard light, but we are still in good range. Also, we can see that the gray is looking nice in our eyes. For the black, we are still under the checker values, so we are still in a high contrast. We have the black 40, 42, 41. Initially, we were getting in the 30-something values, so we are not very far from the previous ones, and we can say that overall this picture in hard light is very well exposed. If we compare this one to the previous one, which we took using the soft light at f11 just to see the brightness, we notice that there's no much big difference in the brightness itself. The main difference is the direction of the light. Here it's from the right, the hard light is from the left. Also, we can see the nature of the shadow is different. Here the shadows are softer because we are using soft light, and previously we had harder shadows because we were using hard light. Other than that, we can say that the brightness is almost the same, and even by looking to the numbers, they are not very far from the previous one. This shows that the light meter has no problem in metering any kind of light, whether it is hard light or soft light. It will always give correct results. So now we are going to turn on the second light. But before doing that, let us think. We have that light tuned at f16 and this one on f11.5, which is around 16. When both lights are turned on, I have source of 16 here and source of 16 there. So when both lights combine together, the light will be stronger. And since both of them are around 16, so I'm giving two 16 sources. This means that light will increase to the next f-stop, and I will be reaching something around f22. It will not be exact because, as you know, this is not exactly 16, but anyway, just the idea. Therefore, I need to meter once again, and either I go higher or I decrease both of them. So f16.7, as I told you, we are going to be more than f16. Will be approaching the next f-stop since we are adding two lights. But since the first light was not tuned at f16, it was half stop below, the combination of these two lights did not reach me exactly to the next f-stop above 16. Now, I am only 3 points away from the next f-stops, so let me add it to see the result. 1, 2, 3. f22. This means both lights were added together to reach the second f-stop. In this picture, we are using two light sources, which are the softbox and the hard light. So now the picture looks a little bit better because we have two lights, one from the right and one from the left. So light is more evenly distributed. But our concern is the exposure. And we can see that the exposure of this picture is really good, and we can see it by numbers as well. If we look to the white values, we see that white is now better than the hard light alone. It's now 247, 248, 244, so we are more approaching the checker values, and the gray is even better. Also, the numbers decreased a little bit, going more towards the checker value, so 147, 148, 150. And the black also decreased a little bit, which also means we have a nice contrast in the picture. So the whole image is looking well and the numbers are very good. I will take a picture on f16 to see how the picture will be burned out a little bit. And I'll take another shot on f11, which means I went down one stop, then 2 stops on the camera. I'm burning the picture twice. In this example, we are trying to see what happens when light is stronger by 1 stop than the settings on the camera. So light here is metered at f22 while our camera is at f16. So the camera is 1 stop less than the light power. We can see by our eyes that the picture is clearly overexposed and the colors are now bright and they are also losing some color values. If we look to the numbers, white is 255, 255, 255. This means that white reached the maximum and it cannot be more white than that. If we look to the gray, a gray is no more gray, it's now approaching the white value. It's in the 200 level, so it is more towards white. It's 200, 203, and 204. So the gray now is almost white. And if we look to the black, we see that the black is no more black. It is approaching gray somehow. It's 83, 84, 82. So if the light is stronger by 1 stop than your camera, you are going to get overexposed images like the one in front of you. And if the light is stronger by 2 stops, like this picture, we can clearly see how the picture is very overexposed, not only in the gray area, but also we lost colors. There are some colors that don't appear anymore. Let's look to the numbers to understand why some colors no more appear. White is previously 255, so here it cannot be more than 255 because this is the maximum that it can reach, so it's overexposed. Now the interesting part is the gray. If we look to the gray, we see now it is 236, 240, 241. These values are almost white because white should be in around 240 based on the Macbeth color checker. So the gray is no more gray. Gray is really white when we are 2 stops overexposing the picture. And if we look to the black is now 100% gray. It's 126, 130, 131. So black is no more black. It is pure gray. We can understand from these numbers that any color which is at the level of 125, it will be overexposed reaching around 255. This means any bright color will turn to white and it will be overexposed. This explains to us why we are losing some colors in the Macbeth checker, because these colors were initially bright colors and by adding 125 points to them, they are burned out and turned to white. So in this example, we saw how overexposing your image will affect the colors greatly, and it gave us a clear understanding by numbers. So this was our light meter tutorial and I hope you liked it and enjoyed it. And also this video will end our Photography 201 series, which was about what is a studio. If you like them, I hope you click like on our videos, and also I invite you to subscribe to our YouTube channel. Thank you and see you in another series.